Hi Quentin, this is Professor Megan Bunnell. I hope all is well. I received your question in your Unit 4 homework about graphing the parabola or the quadratic function. So I wanted to make you a quick video on how to solve this problem since there are a few steps to it. So this problem asks us to use the vertex and intercepts to sketch the graph of the quadratic function. Then we want to identify the axis of symmetry and the domain and the range. So the first step is to sketch the graph. In order to sketch the graph, we want to identify the intercepts and the vertex. The first step in doing that is to rewrite the equation in the form f of x equals a times x minus h squared plus k. And all that means is that we want the squared part of our equation to come first, and then our constant, or just the number, is going to come last or after the squared part. If we look at our problem, we can see that we need to move this 1 so that it's after the parentheses and squared part. Since the number 1 is positive, we're going to put a plus 1 after that squared portion of the equation. So when we move that number, our new equation is f of x equals negative x minus 3 squared plus 1. This will make identifying the vertex easier. So the first thing we want to do is identify the value for a. And a is an important number to know because it tells us if the parabola is going to open up or if it's going to open down. A in this case is the number in front of the parentheses. So our number is just a negative sign. If we don't have a number in front of the negative sign, we can assume that there's a 1 there. So that means that A is negative 1. If A is less than 0, which it is, then our parabola is going to open down. And this is just good to know. That means it's going to be this option here. And this is good to know when we go to sketch our graph to make sure that we're plotting our points right and that the parabola is indeed opening down. The next thing we're going to do is identify the vertex. And the vertex is given by HK. So if we look at the standard form, which is in this form, a times x minus h squared plus k, all we have to do is identify the numbers that are in the h position and the k position to find our vertex. So the number in the h position is going to be the number within parentheses. So that corresponds to the number 3. That means that our h is 3. Now we want to find the value for k. The k is the number that's being added or subtracted to the squared portion of our equation. And that number corresponds to a positive 1 in our equation, so k is 1. That means that the vertex is 3, 1. That's the ordered pair for the vertex. Now we want to find the x-intercepts. The x-intercepts are found by replacing f of x with 0. So you want to set the equation equal to 0 and then solve for x. So we plugged in a 0 here for f of x, and now we're just going to solve for x. To do that, first you want to subtract 1 from both sides. So 0 minus 1 is a negative 1, and that equals negative x minus 3 squared. Now we'll divide both sides by negative 1. They go away on the right side, and then negative 1 divided by negative 1 is a positive 1 on the left side, and that equals x minus 3 squared. We'll get rid of the exponent of 2 by taking the square root of both sides. Whenever we take the square root of a whole number, you always want to write the plus minus sign next to the square root. So the square root of 1 is a plus or minus 1. And then the square root of x minus 3 squared is x minus 3. Next, we'll add 3 to both sides to isolate the x. So we have 3 plus or minus 1 equals x. That means that x can either equal 3 plus 1 or x equals 3 minus 1. So x equals 4 and x equals 2. Those are going to be the points on the x-axis, which are x-intercepts. So the ordered pair for x-intercepts would be 4, 0 and 2, 0. Now that we know the x-intercepts and the vertex, we can sketch the graph in My Math Lab, and I'll show you how to do that within My Math Lab. When you click on the button that says click to enlarge graph, you'll see a window that opens up and it looks like this. So we want to graph a parabola, which is the button here. So we're going to click that button, and once we do so, we're going to plot the vertex. So remember, the vertex was found to be 3, 1. So we'll go over 3 and up 1, so we'll put a point here. So you'll just take your mouse and place a point right at 3, 1. When you do that, you'll get something that looks like this. So there's a line and there's a point at 3, 1. And in this yellow bar here, it will tell you that there was a point at 3, 1. So that's your vertex. Now you need to click the graph to plot another point on your parabola. All you need to do is plot one x-intercept, and then the computer will automatically graph the rest of the parabola. So our x-intercepts were at 4 and 2. So we could either plot 4, 0 or 2, 0. I'm going to plot 2, 0. So all you do is you find the 2 on the x-axis and you just click that point here. Once you do that, the computer will automatically draw your parabola. So this is what you will see. And you'll see that they graphed the vertex, okay, that's the top point here, and then the x-intercept at 2, 0, then they drew the parabola for you. And that's all you need to do. You do not need to plot any other point. You just need to plot those 2 points and then click Save. Once you save it, then the computer will bring you back to the original question, and you'll see that this graph is plotted. Now you need to identify the axis of symmetry, the domain, and the range. This is what your question will look like when you completed the problem. Notice that the next question after you graph the parabola asks you about the axis of symmetry. The axis of symmetry is always at x equals h. And the vertex, remember, was hk. And we said that the vertex was 3, 1. So that means that h is 3, so the axis of symmetry is x equals 3, which is this line here. And you don't have to graph that. You just have to write x equals 3. And you want to include the x equals part in this answer because x equals 3 is an equation of a line. So it's not just a number. We have to include the x equals because that tells us that it's a line. Now we want to identify the function's domain. The domain corresponds to the x-axis and the x-coordinates of all ordered pairs. So you're going to look at it from side to side. So if we look at this parabola, we can see that the parabola keeps opening downward, and it's going to go to the left as it continues, and it's going to go to the right as it continues. So that means that as it grows and gets bigger, that it's going to go to negative infinity on the left side, and it's going to go to positive infinity on the right side. So the domain is negative infinity to positive infinity. Now we want to identify the range. The range corresponds to the y values. So how high will the graph go and how low will the graph go? So as we can see, if we look from top to bottom of this graph, the graph cannot go any higher than this point right here. And that corresponds to 1 on the y-axis. So it can't go past 1 on that y-axis. Now if we look to see how low it can go, the parabola is going to keep on going because it continues to stretch out and open downward. So since it continues and continues, it can go low as it wants to go towards negative infinity. So that means that our range is from negative infinity to 1. And we'll write the smaller value first, which is negative infinity. And you always write infinity signs with parentheses next to them. And then comma, and it will go until the number 1. And 1 is included. It actually is at that point, number 1, so we can write a bracket next to the 1. And that's our answer for the range. Once you complete those parts and graph your parabola, then your problem is complete. If you have any other questions, please let me know. Please email me. You can also call me, and we'll try to clear up any questions you have.